In this video, again, we're looking at a selection of calculus questions, kind of more rules based in this video, part 5. In this question, part C, we'll just do part 1. We're asked to use differentiation to find the rate. So f prime t, straight away. E to the power of x goes to e to the power of x, so 5,000. E to the power of 0.04t goes to the same thing, and then we're going to multiply by the differentiated power, which is 0.04. 4% of 5,000 is 200, so we get 200 e to the power 0.04t, and we're told t is 3.5, so f prime 3.5 is equal to 200 e to the power 0.04 by 3.5, and that gives 230 euro per year is the rate of change when t is equal to 3.5. It's always good to have this in your back pocket, differentiations from first principles. So just follow the series of rules. F of x is equal to x squared minus 7x minus 10. If you sat in my class, we write the answer first. 2x minus 7 is what happens if you differentiate this. We'll see the answer appearing. We want to find f of x plus h. Go to previous videos if you want an understanding of exactly what's happening here. X plus h to be squared minus 7 times x plus h minus 10. So this is going to be x squared plus 2xh plus h squared minus 7x minus 7h minus 10. This is f of x plus h. So this is giveaway marks for those guys that are willing to prepare for it. We want to take away f of x. So let's see what happens there. Minus f of x is going to be minus x squared plus 7x and plus 10. So we line them up. So if we have f of x plus h minus f of x, we're going to get 2xh. I'm going to bring the 7h beside it, minus 7h, and then plus h squared. So you should be able to see the answer in this part of the question. The answer is 2x minus 7. The reminder is, what do we have to do? We have to get rid of h. How do we do that? We divide the whole expression by h. All over h is equal to 2x minus 7 plus h. And how do we get rid of h? Well, if it tends to 0, so the limit of this function as h tends to 0, and the function is f of x plus h minus f of x divided by h will be equal to 2x minus 7. Again, giveaway marks if you have practiced it. We have another function here that you should identify straight away, is quotient rule. And you could go to the tables if you're really not sure what to do, but to differentiate a quotient, g prime x, like the previous question, we write down the answer to each part first. If we differentiate the top, we get 6, and if we differentiate the bottom, we get 4x cubed. On the bottom, we always have the bottom to be squared, x to the power 4 plus 3 to be squared. Start with the bottom. It reminds you that on the top we also start with the bottom because there's a minus sign in the middle here, so it's important to get the order right. So it's the bottom, x to the power 4 plus 3 by the top differentiated, minus the top 6x minus 1 by the bottom differentiated, 6x plus 1 by the bottom differentiated. We're asked to find g prime minus 2, so we could sub minus 2 in now, or we could simplify it down. Let's simplify it down first. G prime x is equal to 6x to the power 4 plus 18. We're going to have minus 24x to the power 4, the 6x by the 4x cubed with the minus sign, and we're going to have minus 4x cubed, all divided by x to the power 4 plus 3 to be squared, and we want g prime minus 2. So this is just calculator substitution unless you want to work it out manually. So sub in 6 by minus 2 to the power 4 is 16. 4 minuses will give a plus. Then we have plus 18 minus 24 by 16 we could have simplified these two obviously first to be minus 18x cubed, or x to the power 4, and then minus 4 by minus 2 cubed is minus 8, all over, we're going to have 16 plus 3 to be squared, and this gives an answer of minus 238 over 19 squared is 381, no, 361, 361, g prime minus 2. So simplify it down and use your calculator. Again, nice easy question. So this is a kind of awkward looking one, but the math involved kind of does work out quite easily. A sequence of functions f0, f1, f2 is defined as follows for x greater than 0. f0 is equal to x to the power 2024, and then for every n is greater than or equal to 1, the function is the derivative of the previous one. So f1 is equal to the derivative of f0. So if we get the derivative of f0, we're going to get 2024, bring the power in front, by x to the power of reduce the power by 1. So this is going to be f1. f2 will be the derivative of this guy, so it's going to be 2023 by 2024 by x to the power of 2022. Is there a pattern that emerges here? The 1 and the 2023 is 2024. The 0 and the 2024 is also 2024. So which fn will be equal to 0? Well, let's just try and work out what would f of 2023 be. That's going to be equal to, well, we're going to have loads of numbers along here, and then we're going to have x to the power of 1. So f2024 will be equal to loads of numbers x to the power of 0, which is equal to 1. So it's still not going to be equal to 0, but now the power comes in front, the 0 comes in front. So f2025 will be equal to loads of numbers x to the power of minus 1, but the number in front of them all will be a 0. So f2025 is equal to 0. Maybe a question you'd leave till the end of the exam and come back and just use a bit of logic to get to the answer. In this question, we have a company growing and selling plants, and we're given this cubic function here for the sales, or the height of a spinach plant, the height of a spinach plant for the first 35 days. And we're asked to estimate the height after 15, so just algebra substitution. W of 15 is equal to 0.667. You're obviously going to write out what you're subbing in, plus 1.5 by 15 squared, and then minus 0.025 by 15 cubed. Check this on a calculator twice. 263.13, and it's in centimeters, millimeters, otherwise it would be a pretty tall plant. Centimeters, millimeters, and it's to the nearest millimeter, so 263 millimeters. Just check it twice on a calculator to be sure. Part 2, just write down the derivative. So w prime x is equal to 0.667 plus 2 by 1.5, so plus 3x, and then minus 3 by 0.025 is 0.075, and that will be x squared. And that's the derivative. We saw a similar question to this in the video 4, a range of values where this guy is greater than 24. It was less than 0 the last time, so we're given the derivative when is 1.1 plus 2.73x minus 0.078x squared greater than 24. Need to multiply by, we could multiply by 100, or we could just use the decimals on the calculator. If I actually multiply by 1000 or use decimals, I'll just multiply by 1000, actually by minus 1000, to get 78x squared. 3 decimal places will be 2730 plus minus 2730x. You don't have to do this. And then the 1.1 by 1000 is going to be 11. Oh, actually need to bring the 24 across as well. I'll do that in a second. Plus 1100 greater than 24,000. Sorry, less than, because we multiplied by the minus, and that will be, and I have multiplied the 1100 by the minus, so minus 1100 and minus, so that's going to give 78x squared minus 2730x, and then that will be plus 24,000, so plus 22,900, less than 0, and doesn't factorize. Oh, maybe it does factorize. No, it doesn't factorize. It doesn't factorize. It's quadratic formula again. We've seen this a few times in these videos. If in doubt, just straight to the quadratic formula, calculator use. I would suggest doing b squared minus 4ac first, rather than typing the whole thing into your calculator. It just makes it a little bit easier. The two values I'm getting here are 21.06 and 13.94. And to the nearest whole number, x would have to be between the higher value 21.06, sorry, 21 to the nearest whole number, and 14 down this end are my two answers for this question. There's another question. We're asked to find a derivative quotient rule. So the top differentiates to 0, the bottom to 10x. If we start with the bottom, we're going to have 5x squared plus 7 to be squared. On the bottom, we have the bottom squared. Start on the top, we're going to have 5x squared plus 7 by the top differentiated, minus the top, which is 1, by the bottom differentiated, which is 10x. So we're just going to get minus 10x on top, and 5x squared plus 7 to be squared on the bottom. You never have to multiply it out. Next question. We have a product rule, it looks like. Tan x over 2 and ln x. Well, tan x over 2 goes to, tan goes to sec squared, and then the angle is going to differentiate to 1 over 2. So we're going to get 1 over 2, the differentiated angle, by sec squared x over 2. Sec squared x over 2. Go to the formula booklet. It's unusual to come up, but it has come up, as you can see. Ln x goes to 1 over x. We've seen that already. 1 over x. So if we take, we want g prime pi over 2. So g prime x first. The first, tan x over 2 by the second differentiated, which is 1 over x, plus the second, ln x, by the first differentiated, which is a half sec squared x over 2. So that's g prime x. So now we have to put pi over 2 in. So we're going to have an angle. So the tan, just off to the side here, pi over 2 over 2. Well, the 2 drops to the bottom, pi over 4, which is 45 degrees. So we have the tan of 45 times 1 over x is 1 over pi over 2, which is 2 over pi. So tan of 45 by 2 over pi is the first one. Then we're going to add the natural log of pi over 2. What are we asked for? To form a plus the natural log of b. So we have natural log in the answer. So natural log of pi over 2 times a half. Now sec squared. Sec squared is 1 over cos squared. Let me just do it up here. Sec squared is 1 over cos squared. So that's, if we imagine 1 over cos by 1 over cos. And the angle is x over 2. It's the same angle again, so it's going to be 45 degrees. So we've got 1 over the cos of 45 by 1 over the cos of 45, which is 1 over root 2 by 1 over root 2, which is equal to 1 over 2. So no harm to simplify it off to the side here. Quite a bit of work involved in that. So we're going to have the sec squared part is going to be, well, let's just do it off to the side. It's going to be x, sec squared is 1 over cos squared, so 1 over 2, which is 2 over 1, just equal to 2. So a half times 2, it looks like here. So this whole part is just going to equal to 1. So we're going to get the tan of 45, which is tan of 45 is equal to 1. So I'm just going to get 2 over pi. Actually simplifies down nicely. We're just going to get 2 over pi. This is equal to 1. 2 over pi plus the natural log of pi over 2. For this one, quite a tricky part, I think, that for most people, but take your time. Maybe another one that you might come to at the end of an exam if you're not 100% sure at the start. Question 9, you might have seen before when we did functions. The lake was stocked with trout. Find the number of trout in the lake when it was first stocked. So t is equal to 0. So this guy here will be equal, e to the power 0 is equal to 1. So we're going to get 1 plus 6.5 on the bottom. So we're going to get 3,000 over 7.5, which is 400. Part 2, we're just subbing in here calculator use. T is equal to 10, 3,000 divided by 1 plus 6.5 e. You could just move the decimal if you wanted. E to the power of minus 8.14, minus 8.14. Or if you just keep it really simple, don't change anything, just in case you make a mistake, minus 0.814 by 10. This will give 2994, correct to the nearest trout. Then we're asked to show the limit, another limit question. The limit is 3000, so what's approaching infinity? As t tends to infinity, we're going to get e to the power of a negative number will be will be 1 over e to the positive number, 1 over, say, e to the power of infinity. Well, that will tend to 0 as e gets bigger and bigger and bigger. So 6.5 by 0 is 0. So we're just going to get 3000 here. Just show that maths in this box. Then we're just asked to solve. Month N is the first month when the trout had ridden above 2650. So when is this expression greater than 2650? So we're going to get 3000 on top over 1 plus 6.5 e to the power minus 0.814t. When is that greater than 2650? If we cross multiply, we'll get 3000 will have to be greater than 1 by 2650, 2650 plus 2650 by 6.5 is 17225, and that will be e to the power minus 0.814t. If we divide by 2650 and move over to the left, we're going to get 3000. No, we take away 2650, we're going to get 3000 minus 2650, 350. And then we'd have to divide by 17225, and then that will be greater than e to the power of minus 0.814t. If we get the natural log of both sides, the natural log of the left over 17225 will have to be greater than minus 0.814t by the natural log of e, which we know is equal to 1. So we just divide this left hand side by minus 0.814. That whole thing, just so I don't have to write it out again, be greater than t, and this is giving me 4.784. So t will have to be equal to 5 for this part. In terms of t, the rate in which the number of trout is increasing, that looks, it's a quotient rule question. We've seen a couple of these in this video already. So quotient rule, the top goes to 0 and the bottom goes to minus 0.814 by 6.5 is minus 5.291. That's multiplying the power by the 6.5 minus 0.814. That's the differentiated angle or the differentiated power, and that would e to the power minus 0.814t. So that's the bottom differentiated. So if we follow our quotient rule, we're going to have on the bottom squared, 1 plus 6.5 e to the power minus 0.814t to be squared. We never have to multiply it. Then on top we have the bottom, 1 plus 6.5 e to the power minus 0.814t by the top differentiated, which is 0, minus the top by the bottom differentiated, which we have as minus 5.291. 91 e to the power of minus 0.814t. And all we need to do is multiply 3000 by minus 5.291 to get 15873. 15873 e to the power of minus 0.814t all over the bottom to be squared. So really the maths involved, when you practice them a few times, it's not massively complicated, but they really are testing for the higher level students that want to get H1s. Stay calm, don't panic, and you should be able to get to the answer quite quickly.